You are welcome to this training on data analysis in R Programming and SPSS. In this training, I'll be showing you how to carry out data analysis using the tools of R Programming and SPSS. And this training is brought to you by Exxon Consult Services and Ecostopin Analytics Consulting Limited. My name is Vincent Essen. As I said earlier on, that in this training I'll be showing you how you can use the R programming tool and also how you can use the SPSS tool for data analysis. That's what I'm going to show you throughout this training throughout this video. So the data set we are going to use for this training is the source of the data set is SPSS. The data set is gotten from SPSS. But the dataset have been imported into an Excel file. I've exported the dataset into an Excel file. So before we can make use of that dataset, we have to import the dataset into SPSS. There are different ways to import dataset into SPSS. But first and foremost, in order to import the dataset into an SPSS, you need a function. Before you can import your dataset into R Studio, you need to make use of a function. So we are going to install the package in which we will use in importing the dataset into our program, and then we are going to use the .install function, and the function we want to use is read xl. That is the function. So once you run this line of code, already gotten this. Once you run the line of code, it will tell you this. Do you want to restart our programming to install? I've already installed this in my system, so I don't need all this. So once you install that, the next thing you have to make it active by making use of the library function. When we make use of the library function, it makes it makes that function active. So when you run this, it makes it active. You can see the console. Okay, that makes a particular function active. Now, once you've done that and you've made it active, the next thing is let's see our working directory. We'll get working directory. I want to see the working directory I'm working with. Now you can see the working directory I'm working on currently. You can see the working directory. This is the working directory. Now you can see the file that I'm working with is located in my document, and this is my document, and I have some list of files. Then I go to R Programming. In this R Programming, my document, that is where the file is located in. So I will set my working directory to that particular folder. So set working directory. Now is very similar to this, or you can see that users, the file is located in my C drive, and in the users, the name of the computer, which is Vim, the document, and our program. Now this is the path. Now that is the path to where the file is located. So I'm going to set that particular path just the way it is, just as you've seen it. But the only thing I'm going to do, I'm only going to change the slash instead of the. Now, this is what I'm going to do now. Okay, now instead of the forward slash, I make use of the backslash. So using the forward slash, I make use of the backslash. So let's run that. Let's see the set working directory. Users slash v slash document slash. Okay, now you can see this R Programming M. Okay, let's run that again. Now, okay, fine. But everything has been set. Now the next thing is to import the file into Excel, into the R Studio. Okay, we are going to import the dataset into R Studio. Now, in order to import the dataset into R Studio, we make use of the function we've just created. So the read underscore the Excel. Now you can see the argument of this function. The name of the file, this is the name of the file, calsales dot that at the extension xl. Okay, we run that function. Now you can see the file. Now the SPSS file that I exported into Excel. Now you can see the file. Now you can see the file, the manufacturer, the modeler, the sales, and the rest of it about the file. More than 147 more rows, 16 more variables. Now let's quickly take a peek and look at the file SPSS. Now this is the file I'm using for this particular training. Is gotten from SPSS car sales, and I exported the file into an Excel spreadsheet and imported it into R Studio. So that is the file we'll be using. So now we've already viewed the file. Also, if you want to view the file, there are also various ways in which you can use, in which you can decide to view your file. There are some ways in which you can decide to view your file. We can decide to view our file in using different ways. Let's view and get us get the structure of our data set. Let's view the structure of our data set. In order to view the structure of our data set, we need to install the package. The package we're going to use the tidyverse. Now, if you don't have the tidyverse, you have to install that into your R programming. The tidyverse. Okay, you have to install the tidyverse function into the R program, but I already have this package here. Once you are done installing, you use the library function to call that function, the tidyverse. Okay, and we can see the spelling here, the tidyverse. Okay, here we have this. I already have the function in my system, and it's already active. I already have it in my R Studio, and it's already active in my R Studio. So you can see the tidyverse. I already have that particular function, so I don't need to do that. So then when you do this, it calls the function, then we are able to view. Then we'll be able to view our data set. So classes so we use the head. So we just want to view the head of our data set. So now you can see that our studio displays the head of the dataset. Manufacturer, sales, resales, to the width of the dataset. So that is just the heading of the dataset. Okay, that's the heading of the dataset. Now when we go to the R program, this is the data view. You can see manufacturer, model, sales, reseller, and so on. So that's the head of the dataset. Then if we want to view the structure of our dataset, to view the structure of the dataset, and to view the structure of the dataset, what we do is this: we use the same car sales. Now this time around, we are going to use the scr function. And this is a function we're going to use, and we run that. Now, running this function gives you this. Now you have the different heads of that. Now, what this function gives you that, so we can view our data structure. Now we view our data structure, we know that we've imported the right data set into our Studio. Now we can start carrying out an analysis on our data set. So in order to, we can plot the scatter plot of seeing the relationship between the two data sets. Also, we can do the histogram, and we can decide to do the histogram. Use the ggplot. Now, using the ggplot, also you have to install the ggplot. If you don't have the ggplot, you go through the same step using the install.packages, and you use the ggplot. While you install that, then you use the library function to recall that particular. You have to recall that using the to make it activate it on ggplot. When if I go to my packages and I type the ggplot, now you can see I have ggplot too. So that means you are installing. Okay, that means the ggplot. But I already have it in my system, so we'll just use that the ggplot function. Now, in the ggplot function, you have the data. Yes, it passes the data as an argument, and that is the car underscore sales. That is the file name. Okay. Then the statistics, that is the statistics. That's the X. The X will be fuel efficiency. MPG. Now, when you go to our data set, you know that the fuel efficiency is the MPG. MPG is the fuel efficiency. MPG is the fuel efficiency. Okay, MPG is for fuel efficiency. So we have the MPG for fuel efficiency, that's Y, and that's X. And the Y for the data set will now be, and the Y will now be sales. Now, when you go to our SPSS, you will see that the sales, the name for that data set is sales. So we'll make use of sales. Then we have to use a plot. If we want to plot the scattergram, we use the geo point. Okay, and sorry, the geo point for the scattergram. Okay, we run this. That gives us the geo point. But let's use the okay. Sorry. Now when we use the geo point, that gives us the scattergram. So let's get the scattergram. We are coming to that. That gives us the scattergram. So we run that. That gives us the scattergram. Then we can change the size. So we can get the thing. Okay, we can just pick a particular thing there. and that gives us the theme. Can decide to choose anything we want. Okay. Then we can decide to increase the size of this. Let's make size equals to 5. Let's run that code. Now you can see the relationship between the sales and the fuel efficiency. You can see as the fuel efficiency increases along the x-axis, the value of that does not lead to an increase in the value of sales. So it looks as if there is no relationship between the fuel efficiency and the sales of vehicle. So now at this point, it is too early to conclude that car manufacturers shouldn't focus on, based on our data set, car manufacturers shouldn't focus on fuel efficiency in order to increase the sales of vehicles. Okay, or the sales for vehicles. Now, what we need to do now, we have to now see the individual data set. No, so we have to now see the individual data set. So let's try to see the individual data set. Let's see the individual data set, and there is the geoplots. Now the data. Now the data set. Now the name of our data set is car sales. Then aesthetics. The aesthetics AES. Now the aesthetics area, when you look, the X should be the sales. Okay, plus sales plus the 0 point with this geo histogram. If I a geo histogram, let's run that line of code. Now you can see the histogram there. Now that is the histogram. So that's the histogram. Now we can decide to add color to that. Decide to add color to that. Let's make the color either black. Okay, and let's run this line of code so we can see. Now you can see that for the sales of the vehicle. Now we can see for the sales that that the histogram is, most of the data set is located on the left hand side. That means it is right skewed. This is skewed to the right. It is skewed to the right because if we want to draw a curve to that, you would want to draw a curve. Now we want a curve to that. Okay, the 0 point requires the following message: x and y and x, okay, y and xn or y and yn. Okay. Yeah. Yes, the 0 point requires that two argument to get the curve. So that is a histogram, and that is the histogram there. So we run the histogram for we to see that, and we see the line there. And we can also decide to this theme color. We already made this theme color. We can also decide to change the theme color here and make it. Can decide to change the theme color. Now we can decide to make the theme color. Let's make this classical. Okay. Now you can see the outliers in this particular dataset. So we can do same thing to fuel efficiency, but fuel efficiency is not a continuous variable. Now fuel efficiency is a discrete variable. The fuel efficiency is a discrete variable, that is the MPG. But it's not going to run because start being requires a continuous x-axis. The x-axis is discrete. Now, it's a discrete variable by nature. It's a discrete variable, so we not getting that. Okay. Now that is the for that. Let's get the scattergram. Now we see the scattergram. Now let's see the. Now we've seen the scattergram. Let's go to SPSS. Now in the SPSS, we are going to see how to draw a scattergram in SPSS. Okay, first and foremost, let's go to analysis. That's the descriptive facts. Okay, let's go to the chart builder. Now in the chart builder, we're going to choose we have the scatter or dot plots. Under the scatter or dot plot, let's see. We have the simple scatter, we have the group scatter, we have the okay. Then I want to see the relationship between fuel efficiency and the sales of vehicle, and the fuel efficiency. Want to see the fuel efficiency. Want to see the relationship between fuel efficiency and sales of vehicle. Sales of vehicle should be on the y-axis, and then I want to set this. Let's see. How do we want to set this? Let's change this. Let's change the single scatter. So let's make it a simple scatter, and the values of all these are okay. And let's click on OK. Now we can see the scattergram. That the scattergram is similar to what we have in R programming. When we run this particular line of code as scattergram, now we see what we have. Now you can see we have similar results. You can see what we have here and we see what we have in SPSS. Now that is scattergram. Now let's recall this in R programming. Let's give out the chart builder. Now the scatter plot. Now we have the scatter dot plot in our program. Now let's see the histogram. Let's drag and drop here. Now we need the sales in thousand and fuel efficiency. Okay. We start with basic elements. The X and Y axis is already chosen. So let's click on OK. So that gives us the histogram for that gives us histogram, but now this time around we are going to do that for the single. Now the histogram excuse me. Now for sales, for the histogram for sales, and then we want it in form of a dot, Okay. Now we have symmetry. We have a symmetry. Now let's see the histogram chart. Now that is in form of a dot. We don't need histogram in form of a dot. Let's go back there. Which elements are available for this kind of chart? Is it I'll make it in the form of a dot? This is not active. Okay, now let's look at that for fuel efficiency. Let's see that for fuel efficiency. Now for fuel efficiency, this is what okay. Now for fuel efficiency, that's the histogram for fuel efficiency. Now you can see that the two fuel efficiency and the sales, fuel efficiency and the sales of cars, you can see both of them. You can see the distribution. Well, that of sales is key to the right, and that of fuel efficiency. Most of our data set is located in the middle. That is to tell you that it is normally distributed. That of fuel efficiency is normally distributed, but that of fuel efficiency is normally distributed, but that of sales is not normally distributed. Okay, that is for the histogram. We've seen the scatter plot. Let's look at other way we can analyze this data set. Now let's see a situation where you can use the box plot. We can use the dot plot. We can use the dot plot. We can use the box plot. Okay. So let's get the dot plot. So ggplot, the data equals to the car sales, then the statistics. The statistics here we are going to use for our statistics. We are going to use the x equals to, now let's start with the x equals to sales, and then plus the geo points. We're going to use, this time we're going to use the dot plot. Let's see the dot plot. Okay, let's see the dot plot. Let's run this. Let's run the dot plot. Let's see. These are the various way of viewing your dataset. Now you can see the dot plot giving us this. Now the dot plot. So we can also go to SPSS and we bring the dot plot scattergram. So let's recall this and we go to the dot plot. Now we go to the gallery. We have the dots of scatter plots. Now you see we have the dot of scatter plots and the gallery. But if I should make use of the group, make use of the group scatter plot instead of the single scatter plot. Make use of the group scatter plot, I need to set the color for the group scatter plot. Okay, let's get a basic element. Let's make this text. Okay, and I come to this. Okay, for sales, in the SPSS for sales, that's for sales. Now I need to set this color. What color am I going to use now for this? We need to set the color. Okay. Now I'm looking at the sales of cars. Okay, so now let's use them. Let's see which model we go for the color. Okay, let's. Okay, as it processes, now we can see the sales of cars and we can see the different sales of cars for the color of cars. Okay, that is the dot plot. We already get started on dot plot. Now, in this particular case of histogram, in this particular case of the scatter plot, okay, scatter plot here we can use, we can decide to see. Now you can see the outliers here. So we can decide to use geotext. We can decide to see geotext. Okay. Okay, now we can decide to see geotext. Under the geotext, we will get the data. The geotext data that is car sales. Then we are going to use the process. So we are going to use other the geotext. We are going to use the filter function declare the filter function declares sales. Okay. Okay. Under the geotext, we are going to use this label equals to model. That is the model of the car. Okay. Then we are going to use the car sales. Okay. Forecast. Now we want to filter that. We want that to display the model of the car. Unexpected in okay. We have to label. Okay. Now let's go to the model of the car and ODELS. We omitted the plus sign there. We've omitted the plus sign while we introduced that. And now let's do the GG. Let's run the GG plot all over again. Now you can see that the S series model of the car is a car that has a sales higher than 400, and that is an outlier in the dataset. And can this also be regarded as outliers? Okay, notice this is the outlier of this particular dataset. So that is the GG plot. So we've done the scatter plot. We've done the histogram for the sales and the fuel efficiency. Now we've done the dot plot. Now that's the other type of scatter plot. Now this is an outlier. That's an outlier if we want to find which particular that has that outlier. We can use this plus let's just see how this is going to run. Let's just see how this is going to run. Okay, let's run this all over again. Okay, now let's work on this. Okay, at this point whereby we create a histogram, and this time where we created a histogram here, we can also decide to this where we can let's see break. Can we work in break? Let's see. Maybe I will break like 50. The first and foremost, before using this break, let's run this Instagram chart again. Now you can see this Instagram chart here is we can decide to add the break there. Let's see if adding the break in this Instagram chart here will yield this. Let's see. Although being with okay, we have two of that there. Okay, now you can see the number increases. Okay, well, you can play with the beam width and you choose a desired beam width that is okay for your data set. So I think the default should be okay for this particular data set. I think the default is okay for that. That's for the sales. And okay, I make use of that should be east. Let's use the east function. Under the east function, we have the class dollar sign, and we have the sales. Okay. Now using the east function, let's run this. Now that gives me the histogram for the class sales. Now if I want to add the break to that, I can. That is to increase the beam because the beam decides the number of bars that will appear in the histogram. In other words, in Instagram makes use of using a value between a particular number with a particular number in order to plot an histogram. So, doing this for Instagram, the number of beam will determines the number of bars you're going to get. But when we are using the is function, we use the break. So I make use of 50. That is, let's try the part of 30. Okay, it's telling unexpected equals to in its break. Now you can see the number increases, so it breaks and not just the break. Take note of that, it breaks. Okay, that's that. Now what we are going to do now, we've done that. We are going to have the box plot, that's the dot plot. We are going to do for the box plot. We are going to do the same thing for the box plot. This for the dot plot. We've done the scatter plot, we've done the dot plot, we've done the histogram. We can simply copy this dot plot for the fuel efficiency MPG, and that we go for the fuel efficiency, and we run that for the fuel efficiency. Now we can see the scatter plot for the fuel efficiency. You can see the description of the data. The description of the data is normally distributed very similar with what we get in SPSS. That is for the box plot, the SPSS. That's the dot plot, sorry. For the dot plot, yeah, that's dot plot for fuel efficiency. Okay, that's for the fuel efficiency, for the fuel efficiency. Okay, and I'll make use of model. Okay, for the fuel efficiency. Okay, let's exercise the questions as the SPSS runs this particular distribution. Now you can see that what we get in using the SPSS is similar to what we got using the R programming software, using the R programming. Okay, also the SPSS, you can decide to increase the size of that box plot in SPSS. Now let's see the box plot. Okay, in the box plot in SPSS, we are going to do something similar. We are going to do the GG plot. Okay, the data set is still the class sales data set, and the statistics for our data set is now we're looking at x equals to the sales. Okay, x equals to sales, and then we get the G plot. Okay, this time around we are working with a box plot. So we have the box plot then. Under the box plot, we have x equals to, the box plot. Okay, let's quickly run this. Then we can see that most of our data sets using the box plot scattergram, most of the data set is skewed to the left. That is say that data set, most of the data set most of the distribution occurred on the left hand side. That is to tell you that it is skewed to the right, and that's skewed to the right. When we use the dot plot for sales, that's for sales. Okay, now you can see that most of the data set now, most of the data set appears on the left hand side. That makes this skew to the left because we want to draw the curves in this way. We want to put a curve, and this way, let's see if the curve will come out. If we can put a curve, just smooth, and let's just see if we can get its curve there. Well, let's see if the curve is able to come out there. So let's run that again. Okay. Okay, let's see. Yes, probably it's taking time to run. Okay, okay, let's do it this way. Instead of doing this, let's see if it will run this way. Yeah, let's see this way it will run this other way around. So the just mode helps to put a curve along data sets. It helps to build a curve along the dataset, but that might be okay. Let's see. Requires the full missing statistics. Why? Okay. Okay, sorry. We use the geosmart when we are working with the x and y axis. While we were doing the scatter plot x and y axis, we could try using the geosmart at this point, but given a dataset, the geosmart will not appear. Given a dataset, so this where we can use the geosmart because it needs x and y axis. We should have x and y axis. Did you forget to add this object something? So okay, let's try adding it and um let's see if it will. Okay, now I'm due to the nature of the dataset. Using method leaves formula list. So the nature of our dataset, can't put a line across this dataset because the dataset is widely distributed. It's not distributed in a single place. Okay, now that's how to draw a line through your dataset. Now we have the box plot. We can also do that. The box plot we can do that for MPG, that's the fuel efficiency. We can analyze that and see. Now you can see that for fuel efficiency using the dot plot, we can see the distribution of data sets. So let's quickly look at the density. But okay, we have the box plot. We've done the box plot. We've done the dot plot, the box plot, and the scattergram. So let's quickly see the density. So we use similar. We're going to do similar thing here. We use the ggplot, but this time around we are using the box plot. So we are using the density. We are using geodensity. Okay. Okay. Now you can see the geodensity. Now you can see that this dataset series is skewed to the. Now in most of the dataset occurs on the left hand side of the chart, so that means it's skewed to the right. Most of them, of course, on the left-hand side of the chart. Most of the data set are stored here. You can see that most of the data set occurred on this part. So that's telling that it's skewed to the right. Now you can see the tail. That means only few data set appears at the start of the chart. So the data set is skewed to the right, and we can find out that for the fuel efficiency. So that for the fuel efficiency would make the X to be that. So now you can see that the fuel efficiency, how the data set is being distributed for the fuel efficiency. Now you can see where we have the fuel efficiency, we have the kind of outliers, and you can see how the data set is also skewed. Okay. Now let's quickly go to SPSS. Let's go to SPSS. Let's recall that. Okay, let's go to the gallery and let's use the box plots. Okay, using the box plot, we have different types of box plots here. So let's just put a simple box plot and let's come to the chart element. Let's see the X. That's what we want to use. Let's see for sales. Okay, let's click on OK. Now you can see for the sales, you can see most of the data set appears on the left hand side of the chart. That means it is skewed to the right. Now it's skewed to the right. Also, we can come back here, the chart builder, and we change that to fuel efficiency. We can do that for fuel efficiency. Okay, we can see that for fuel efficiency. We can see that for fuel efficiency error. Okay. Let's click on OK. Now we can see for the fuel efficiency, most of the data set is skewed to the middle of the chart. This will tell you that this is normally distributed. The fuel efficiency is normally distributed. No wonder when we do the scatter plots showing the relationship between, when we look at the scatter plot showing the relationship between these two data sets, so we can know what type of regression analysis to run on this particular data set. We can see that it shows no relationship between sales and fuel efficiency. In other words, the car manufacturer should not only focus on fuel efficiency in the design of car, because fuel efficiency will not actually, at the end of the day, will not actually lead to an increase in the sales of the car. Don't forget to contact us for your training on data analysis, data science, R Programming, Python, project management, computers for beginner, and other IT professional courses. Just contact us on our contact line via WhatsApp 791 30969 or contact us via contact us also at our office at number 150 Agro Palace Way, Port Lagos. See you.